37, while the average is taken to be 35 parts per thousand. In landlocked areas, in the lower latitudes, what will happen? The temperature will be higher. Temperature being higher means what? There will be more evaporation. More evaporation means what? There will be removal of water. That will lead to increased salinity. So, in landlocked Red Sea, you will find that salinity is as high as 41 parts per thousand. While in the region around Arctic, in the region where the estuaries are formed, that is as the river enters and meets the sea, in those areas you have enough supply of fresh water. In the Arctic, during the summer, what happens? All the frozen areas, they melt, means addition of water. In again the winter season, everything will freeze, means removal of water. So that is why you will find that in the region of the Arctic, the salinity tends to vary from 0 to 35 parts per thousand. 0 is when everything melts. There is absolute supply of fresh water. Keep one thing in mind, that at low latitudes, when you have enclosed seas, whenever you have enclosed seas at low latitude, that will lead to increased temperature. When you have an increased temperature, as a result of that, what will happen? Evaporation, which is observed, evaporation will be high. When the evaporation is high, that leads to removal of water. When there is removal of water, salinity. Okay? So this is what you have as the phenomena which is observed in the region around Red Sea, Mediterranean Sea. Mediterranean Sea also has a higher salinity content. If you look at here, this shows you the variation of salinity in various parts of the globe. Now here, I want you to look at Bay of Bengal. If you observe Bay of Bengal, compare it with Arabian Sea. Now here the blue color indicates a reduction in salinity. A yellowish to reddish color represents an increased salinity. Here you will observe that in the region of Bay of Bengal, salinity is going to be very low. Why is that? Because in Bay of Bengal, you have rivers such as Brahmaputra, Irrawaddy from Myanmar, Godavari, all of them, they empty themselves into Bay of Bengal. Whereas in the case of Arabian Sea, you have Narmada, Tapi, and Indus. That is nowhere as big as these large rivers. So because of this excess addition of fresh water from the river sources, you have salinity in Bay of Bengal to be low. Look at Mediterranean Sea here because of influx of river water. The salinity is going to be low. Now, if you observe the region around Mediterranean, in the region around Mediterranean, you will observe very high salinity. Why? This is because of increased evaporation. You will observe the salinity to be high in these areas as well. Why? Because these are in the tropics. So the tropical regions will always experience a higher salinity when compared to the regions which are in the equator. Okay? Now, here, this tells you that, for example, if you observe this particular figure, let me zoom this in so that you are able to look at it carefully. See, whenever you come across any map, any figure in geography, as an ideal student, as an ideal candidate, you have to analyze each and every detail. So, for example, look at this region. You will observe that here the salinity is low because, again, there's an influx of water. Here again, salinity is low, influx of water. Excuse me. So, wherever there is influx of water or there is melting activity, automatically salinity shall be significantly low. Okay? Now, in hot and dry regions where evaporation is high, sometimes the salinity reaches up till 70 parts per thousand. Maximum salinity is observed between 20° north and 30° north. Why not south? Why north? Because north is predominated by land. The northern hemisphere is predominated by land. And land leads to an increased heating. So due to this increased heating in the tropics, which generally don't have rainfall because of the sinking air, there's lack of precipitation, but the temperature is high. That leads to an increased evaporation. And that is why in the between 20° north to 30° north, salinity tends to peak, salinity tends to be very high. Okay? Now, the North Sea, being in higher latitudes, it does record higher salinity due to more saline water brought by the North Atlantic Drift, which tells you that the ocean currents, they also bring in a factor of salinity. This is being talked about of this region. You will observe that all around it, in the similar latitude, you will have very low salinity, but here the salinity is high. Why? Because the ocean current which comes through, that ocean current comes from the lower latitude, and that brings about an increased salt presence with it. And that is why the salinity tends to increase. So this is how salinity tends to vary. Now we have already seen this, so there is no point of this question, but I will check your mental awareness nonetheless. I hope that few of you will still surprise me. Which of the following has more salinity? How many of you feel one is the answer? How many of you feel two is the answer? So, as I said, few of you will still surprise me. Always, in these two cases, Arabian Sea will have more salinity. Why? Because in Bay of Bengal, there will be more influx of river water. River water will always lead to addition of water molecules. Okay? Now, here, I want you to look at another concept. So, when we talk about salinity, let us talk about two different samples. Let's name this sample A. Let's name the another one as sample B. Now, in the case of sample A, let's say that here you have the water molecules. And you have few salt molecules. In the case of sample B, you have the presence of water molecules and along with water, you also have the presence of salt molecules. But here, salt molecules are greater. Now, out of these two, which one do you think will be heavier? How many of you feel it is A which is going to be heavier? And how many of you feel it is B which is going to be heavier? Good. So B is going to be heavier because it has more salt present in it. So when we talk about salinity, an area which has, or a water body which has increased salinity also means that particular water body will have an increased weight as well, right? So by that virtue, when you consider, let's say, an ocean water, let's say the Bay of Bengal, and you have the river water from River Ganga, which is entering into the Bay of Bengal. So River Ganga will bring in fresh water. Bay of Bengal will have saline water. So can we not say that when we consider Bay of Bengal, it will have two different layers? The fresh water being lighter, it will tend to float over the more saline water. Why? Because more saline water is going to be heavier. So in vertical distribution, you will always end up finding that water of reduced salinity will end up floating over water of higher salinity. Why? Because water of reduced salinity or kind of fresh water will always be lighter because there will be lesser molecules of salt. Water of increased salinity will always be heavier because of increased presence of salt, right? Now comes the concept. So, when you have a layer of fresh water clearly floating on top the heavier water, this arrangement or this sorting of the water according to its density, according to its weight, is what is referred to as ocean stratification. Stratification refers to arrangement of water in various different layers depending upon its weight. Okay, so that is what is the ocean stratification. Ocean stratification will be when water is arranged automatically in terms of its weight, right? More saline water will automatically sink to the bottom, less saline water will float on top. So in Bay of Bengal, because you have so many rivers exiting and emptying themselves into Bay of Bengal, that means supply of fresh water will be huge. So in Bay of Bengal, can we not say there will be a clear-cut ocean stratification? Can we say this? Right? So in Bay of Bengal, there will be a clear arrangement of water. Fresh water will float at top, thicker and denser water will remain at bottom. Now what happens as a result of this? Now suppose there is the summer season. The solar rays are falling on this. This floating layer, which is present in a thin depth, that region will get heated up very intensively. Why? Because this floating region, when you observe, that floating region, it shall be separated from the rest. So under those conditions, that particular region will get heated up quickly. Heated at a quicker pace. It gets heated at a quicker pace. So in Bay of Bengal, because there is so much water which is coming in, salinity on top is always low. So that makes a clear where the lighter portion or the lesser saline portion is on top. This leads to an increased heating of the surface. And when there is an increased heating, what will happen? There will be formation of a tropical cyclone. So that is also one of the reasons why Bay of Bengal under general circumstances experiences more tropical cyclones being formed. Okay, because the water gets heated up very quickly because there is a separation in the layers of water. If the water had been homogeneous, then basically to heat that homogeneous layer you require a prolonged heating. But because the water is arranged in different layers, the heating happens at a very quick pace. That is why Bay of Bengal experiences more tropical cyclones under general circumstances. Are we clear with this? Beautiful. How many of you have doubts in this? How many of you have doubts in the stratification of water? Okay. Are we clear with this one? Which will be heavier? How many of you have doubts in this? Why anybody will be heavier? Anybody who has doubt in this? Right. So if this is clear, that water body which has more salt will be heavier, think about the whole of the Bay of Bengal. And if you observe that Bay of Bengal will also have salty water, saline water, rivers which are emptying themselves into Bay of Bengal every second, they will have less saline water. So that less saline water tends to stay at top, whereas the heavier saline water goes to the bottom. So this water layer which tends to stay at top, that gets heated at a quicker rate because there's a difference in the structure, difference in the layer, etc. So that is why you will find that this layer gets heated up at a much accelerated and much quicker pace. And that is also one of the reasons why Bay of Bengal experiences greater heating and accelerated heating. And whenever there is an accelerated heating, you would have observed that one of the necessary conditions or preconditions for the formation of tropical cyclone is that the sea surface temperature should be more than 27 degrees Celsius. So whenever the sea surface temperature increases, that forms an ideal condition for the formation of tropical cyclone. So in general, due to global warming, the sea surface temperature is rising. That is why more cyclones are occurring. But in the case of Bay of Bengal, this heating takes place at an accelerated rate, and that is why you have more tropical cyclones which are observed, which are actually formed. Okay? Now, here, then we move on into how salinity tends to vary as you move into the depths of it. By the way, this reason for the formation of tropical cyclone, you will not find in many of the texts, many of the books. So if you want, you can note it down in a point that ocean stratification accentuates the formation of tropical cyclones in the Bay of Bengal. This reason, if you write in the answer, it will give you more brownie points for that matter. Now, vertical distribution of salinity. When we talk about salinity and the variation of salinity with depth, at the bottom regions, that is the bottom 3 to 4 kilometers or 2 to 3 kilometers of depth of ocean water, salinity is largely constant. Salinity ends up varying near the top of it. That equator will have a lesser salinity as compared to the tropics, etc. At the bottom, wherever you are, salinity will be almost fixed. So that is why the variation of salinity from surface to the depth will vary. It will not be fixed because in the region of the tropics, the salinity at the surface will be very high, right? In the case of the equator, the salinity at the surface will be very or not very high, but will be low. So in each of the cases, as you go to the bottom, because in the salinity is fixed, because there is not much circulation happening in the bottom. And anyways, the more saline water, more salts, they will settle down near the bottom under the influence of gravity. So that is why more saline water or a fixed saline water will be present at the bottom, whereas on top the salinity will be varying. There is, just like we have seen a zone of transition under thermocline, even in the case of salinity, there is a zone of transition which is halocline. Halo here represents salt. So halocline measures the change in salinity zone, and it in fact demarcates a distinct zone where the salinity changes. Okay, now here surface salinity we have already studied and how it varies. Salinity at depth is very much fixed. It does not change significantly. Now here you will observe, let's say here this is 35, right? Let's say this is 35.5. Now here you will observe, look at it, tropics, equator, and closer to the poles. Closer to the poles, the salinity will be less anyways. So look at the base. At the bottom, the salinity is almost fixed. But from top, salinity is going to be maximum around the tropics. So it has got to decrease to reach the fixed amount. This transition where the salinity is varying, halocline. Around equator, the salinity is between 35 to 35.5. At the base, it is around 35. Around the poles, the higher latitude, the salinity is 34. It increases to 35 at the base. So in the case of the tropics, salinity ends up reducing by the time it reaches the base. In the case, because here the surface evaporation is so high that the surface salinity will be higher. Here in the tropics, because of precipitation which happens, the salinity is around 35, 35.5. It goes to the region around 35 at the bottom. Around the poles, at higher latitude, at the surface, the salinity is low because of the consistent melting activity which is going on. So that is why here in higher latitude, you will have a considerably lower salinity, because here, if you will consider, look at this figure. Here you will find in the polar region, in the higher latitude, there is precipitation which is present, even though how less, but evaporation is almost absent. So that is the reason. Because evaporation is almost absent, there is no removal of water which is taking place. That is why in the higher latitudes, closer to the poles, the salinity will always be at the lower end of the spectrum. Okay? Now, higher salinity is much more denser and stays below the water having lower salinity, because higher salinity means more materials packed into the same volume. That means an increased density. So higher the density, deeper it is. This leads to arrangement of ocean water into various layers, which is nothing but arrangement of oceans or ocean water into different layers. That is what is referred to as ocean stratification. Now, this is the data that you have regarding the areas which have one of the highest salinity. So you have Lake Van in Turkey. It has almost 330 grams of salt per kg of water. Dead Sea has almost 238 grams of salt per kg of water. Great Salt Lake in United States has 220 grams of salt per kg of water. So these are the basically one of the most saline regions across the world that you will come across. Now, difference in the density of water leads the water to have varying depth, whether the water will sink or whether the water will float. If the density is going to be low, it is going to stay at top. If the density is going to be high, it is going to stay at the bottom. Now, water with high salinity is generally denser than water with low salinity. But at the same time, cold water is also denser as compared to the warm water. So there is always going to be an interplay between them. That is, depending upon whether the water is very hot, that means water will expand a bit. Even though it will have a higher salinity, but still the volume will be more because temperature is higher. Now suppose water is very, very cold, but it has very less salinity. Still, when compared to another water which has high salinity, its density will be slightly lower. So both these factors are at play together. And these two factors, the temperature of water and also the salt present in the water, it brings about or it initiates circulation of water from one region to another, where the less dense water, water which has less density, that water tends to stay on top. It tends to move to that area which has greater density. Because understand this thing. Suppose, and try to imagine it here. Suppose in one region, I have water with low density. In another region, I have water which has very high density. Right? So, here, let's say I have low density because of high temperature. Here, let's say I have high density because of low temperature. Now, because of high temperature, everything tends to expand a bit. So water column will also tend to expand a bit. Here, water column will get compressed a bit. Here, water column will try to expand a bit. This creates a kind of a height difference, very minutely so. But this does create a kind of a height difference. In fact, around the equatorial region, around the tropical region, when the temperature is very high, regardless of the salinity level, because the heating is so much, water tends to expand, it tends to inflate a bit. There is a height difference of around 8 centimeters, which is gained in the water which is lying in the region of equator and tropics to the water which is lying in the region of colder or higher latitude. This initiates a movement. This movement that you observe, where warmer water comes from the lower latitudes. Here you have lower latitude. And here you have higher latitude. So warmer water comes from lower latitude to the colder region. There, when it comes to the higher latitude, it comes in contact with the ice sheets, very low temperature. So water temperature will reduce significantly. By virtue of that, water becomes heavier, its density increases. And when the density of water suddenly increases, start to sink already regions of lower latitude which have a greater volume, lesser density. Here, as the density increases by virtue of decrease in temperature, it will sink down. But it will not sink all the way to the bottom. It will sink to the layer beyond which you have lesser salinity water. This water, deeper water, anyways will have higher salinity. So it will sink up to a level. After sinking up to a level, this will go and try to reach that area from which water has moved. Because when the water would have moved from that region of higher temperature, it would have brought about a kind of a vacancy. So this subsurface movement goes on to fill that vacancy. This brings about a circulation of water. And because this circulation is brought about by the effect of temperature and salt presence, both of them which manage the density. This kind of circulation is what is referred to as thermohaline circulation. This circulation is what is referred to as a thermohaline circulation. Okay, a circulation which is a resultant of temperature and salinity change, because both of them, they end up controlling the density. More dense water will always be heavier, it will always sink. Lighter or less dense water will always tend to stay on top. Okay, so that creates a base from where we understood what is a thermohaline circulation. Now, till now, we have covered the properties of water, the physical properties of water. Now we shall be looking at the movement which is present in the water. Water also ends up observing a movement. So first we'll look at tides and waves, and then we shall be looking at the ocean currents. Okay, are we comfortable till here? Good. Now, let us take a break. It's around 7:10. Let's come around 7:16 or 7:17. Prashant Kumar, water has maximum density at 4 degrees Celsius, a physics fact. Any correlation? It is that fact that we were talking about, Prashant. Anyways, let's take a break. Let's come back.